Hey, I just wanted to make a quick video on how to make your own superregen FM radio. Um, and I guess before I get into it, I'll just kind of turn it on and show you what it sounds like. Or anyway, you get the idea. It works pretty well, considering it only uses a single tube and it's kind of just a random schematic I found on the internet. It works quite well, but it took quite a while to get it to work properly. And okay, so let's get right into it. So this is the schematic that you'll commonly see on the internet. If you just Google super regeneration FM radio, you'll and just look at Google Images or something, you'll probably see something like this. And yeah, that's basically the schematic. It uses a single tube, which is the 12EC8, and you can get that online, basically on eBay or tubesandmore.com. But before I get into too many details, I've built, before a crystal. Here's a foxhole radio that I built, and this is a AM super regen radio called a Morgan Regen, and I built this basically off another guy on YouTube. Made a video called Morgan Regen, and you can just YouTube that, and he has a schematic and everything on there to build that. So I'd recommend getting into AM kind of before FM, but what I like about this is I have had luck with just using a single antenna here, which kind of acts as a dipole antenna off of my ground plane, and and it runs off batteries, and so I think that's a plus. And it's only 12 volts because it uses what's called a space charge tube. It's only 12 volts. But with AM, it's a little bit easier, and also it has a lot to offer. But the only drawback is I hadn't had luck getting it to work with a short antenna. I've always had to use like 200-foot antenna, tethered along some trees in my yard and then connecting it up. But regeneration radios in general is super interesting for AM, so I'll make some videos later for those. But I started out making a foxhole radio, which is basically a crystal radio, and that was maybe a few months ago, and that was kind of my first project. And now I'm on to building this, which is probably my favorite one so far. And I haven't seen a lot of FM stuff on YouTube or anywhere else at all, so I'm gonna make a video trying to help people build their own. Okay, so basically I just want to go over some highlights, and you can kind of work on your own design. But here's a schematic, and I just want to point out a couple of things to make note of. So for one, at first I was kind of confused because this is minus 12 volts. This is plus 12 volts. So at first I was like, well, is this 24 volts or what? But really, when you look at it, this is ground. It's pretty obvious here. So that threw me off at first. I would not say minus 12, but whatever. And also, at first when I looked at this, I was kind of concerned. I was like, well, does this take a dual supply? And this is minus 12, this is plus 12, and there's ground somewhere else. But no, obviously after looking at it a little bit longer, yeah, it's just ground. So don't get scared by that. And then finally, here's a little transformer there. And this capacitor here is kind of important. But let me get in. There's generally some notes here that also outline some of the RF stuff here has to be really tight. So let me start with the hardest part, and that's this capacitor here, 8 to 12 puff per section, to 8 to 12 picofarads per section, and it's a center tapped, and so it's a dual gain capacitor. And here's what I have. So I took this out of an old radio, and I got really lucky because this is hard to find, but some people might find this the smaller kind. But here's the 8 to 12, these two ends here, basically just, there's like a single 2 pieces of copper here, and that's enough to give you the capacitance. I'm just ignoring this, I don't use that, and you can see that the light's not very good, but it's kind of tapped off there, and basically here the center tap here is just the ground of the capacitor. So I have this ground connected to the ground plane here, and you'll notice here this is 6 turns here, center tapped here with the choke there and 2 puff there, and you can see that I have a 6-turn winding there, and let me get a screwdriver or something. And here you can see it's center tapped there, and there's a choke here, and these are just buttons actually. My wife gave me some of her buttons, and I put some copper tape on them and stuck them on there. The buttons have to be kind of thick enough where it's not going to be too close to the ground plane, otherwise there might be, I was worried about too much capacitance from those nodes to ground, and that causes issues because you're talking about very small capacitances here that you have to work with. The choke here is used so that basically you have a bunch of RF stuff here, so this all needs to be really tight and close together, and then this is a super regen, so it's going to oscillate, and it's going to oscillate at something like 60 kilohertz, and you're going to see basically a 60 kilohertz sine wave. And on top of that sine wave, that amplitude of that sine wave will go up and down with audio, okay? Basically how it works is it's something called slope detection. And the way I look at it, it's converting FM to AM. So converting a frequency modulated signal into an amplitude signal, because the amplitude of that oscillation is going to change with the frequency of the carrier. So as the carrier changes frequency, which is the frequency is changing with the audio, the amplitude of the signal here is going to modulate. And basically what this choke does is it filters out all the RF stuff and just gives you your audio. So your audio and your 60 kilohertz that it's riding on is going to go through this transformer here, which is a 1 to 3 transformer or better, which I have down here, and that's going to feed it into the pentode, which is basically here is just an amplifier. And you can hook up your speakers, or well, you'll need some gain, so just like a LM386 or something, which is a very common amplifier. You can hook it up there and listen to some of the tunes that way. This 2 picofarad here, I have it hooked up kind of like this. You can see this 2 picofarad is connected right here to this node here of this winding, and the reason for that is so that your antenna is isolated. It doesn't detune your circuit. If this was connected directly, then you'd have capacitance from your antenna detuning your tuned circuit here. Okay, what else? Basically, I tried a lot of different things to get this to work properly, and I'm doing something where I'm taking the audio coming out of this and I'm putting it into 6 op amps here that are filtering out the 60 kilohertz. Just each one of those is a low pass filter, and then it's amplifying the signal, and then it's putting it into This is a TDA 7294 amplifier. It's a dual supply amplifier, and that's going into the speaker here. But you don't have to do all that. If you don't have a lot of experience, you can just look up the LM386, which is a very common TI little chip, and you don't need a dual supply. That'll run straight off 12 volts. And I mentioned earlier, one of the advantages of this tube is it runs off of 12 volts. So all you need is, here I used 8 C-cell batteries to give me 12 volts, and put them all in series, and it'll run your tube, it'll run your LM386, and that's it. And this all with the ground plane and all this fancy wiring. I didn't have to get too fancy with it at first. Before I did all this, I'd built up just a little quick mock-up, and it still worked on my bench. And I have another video where I showed all these wires coming off of this thing, and it's still working. So don't have to get too crazy. But one very important thing here, I noticed that when I did build it with a battery, when I had it with a supply, with a DC supply, it was working great. But with the battery has some impedance, so I really had to bump this up. And if I didn't have this high enough, I'd get this awful squealing that would just destroy my ears, and I probably went a little deaf from it. But this, I have bumped this up to 4700 microfarad, and to really keep this supply, 12 volt supply, stiff. Because what happens is, if this doesn't have a low enough impedance to really keep this supply stiff, then this 12 volts is gonna go up and down with your audio, since I'm going into another amplifier, things like that, and that's also off the 12 volts. This will start going up and down. As this goes up and down, it'll go into this pentode here, and this goes up and down, and then this will amplify it. And as that amplifies it, it's going to make it go up and down even more, and then it's just going to go in a positive feedback loop, and you'll get it'll just be really bad. So this really needs to be quite stiff. So 4700 microfarads is good enough for that if you're using batteries. And what that'll allow you to do is be able to shift this resistor to basically the highest point to give this enough gain. And you'll have to experiment a little bit. I had to do a lot of experimentation here. Basically, one of the things I noticed was